Hi, I'm Lefty, and this is Team Panda. We'll be talking about heavy construction industry projects. What is heavy industrial construction projects? That are large facilities of raw material extraction, power generation, manufacturing, among others. Some of the main characteristics of these projects is they're really complicated and specialized.
Hi, I'm Tony. I'm introducing Case Study 1, Olkiluoto Nuclear Power Plant. The project started in July 2005. Olkiluoto, Finland. The main contractor of the project named Avira from France. The basic construction process is similar to general industry facilities. Just like majority of nuclear power plant, Olkiluoto Unit 3 is built at seaside for adequate water supply as cooling water and being boiled. And of course it's built in a seismic-free zone. Also, it will be not too far from publics in order to minimize transport loss. Also, not too close. The main structure includes a concrete tower contains nuclear reactors and unique construction equipment was used, for example special heavy lifting crane and the concrete pump tower. Also, the high strength concrete is demanded to match the higher design standard. Typical nuclear project demands long construction duration and cost. Olkiluoto Unit 3 was planned to complete at 2010 with a fixed price of 3 billion euros. In fact, the project suffered a severe delay and over budget since various problems with planning, supervision, and workmanship. The project is facing a 6-year delay and 5.5 billion euro overrun.
Hi, this is Jason, and I'll present a case study about Perdido Oil Platform. An oil platform is a large offshore structure with facilities to drill wells to extract and process oil and natural gas. And this is the deepest one in the world. The structure of the spar-type platform has two parts. The bottom part, called spar, was constructed by Technip in Finland, and the top side was constructed by Kiewit Offshore Service. 18,000 tons of steel was used to build the spar. The hard tank, connecting truss, and the soft tank were constructed separately and then assembled on assembly rail utilizing cranes. It was then transported to the final destination from Finland to the Gulf of Mexico, and then stabilized by pumping water into the tanks and suction anchors. On the other hand, the top side was built by Kiewit. 9,500 tons of metal was used, and it has 3 decks for a drilling rig, processing unit, and a living area. Fireproof coating and protection panels were used in case of explosion. It was then transported to the site. And the top side and the bottom side, which is the spar, were assembled together, utilizing a crane barge.
Hi, I'm Rahul Ramaswamy, and today I'm going to talk about industrial process plants. Industrial process plants include petroleum plants, natural gas processing plants, and manufacturing facilities. In this presentation, I'm going to focus on manufacturing plants through a case study of a cement manufacturing plant. The case in study is a cement plant in St. Genevieve, Missouri, constructed by F.L. Smith at a cost of $973 million. It has an annual capacity of 4 million tons, producing almost 12,000 tons of cement per day. It is one of the largest and most environmentally efficient cement plant in the world. The project site is located close to the raw material source, that is, near the limestone quarry, and its close proximity to river transport makes the site location ideal. The project began with the feasibility study and design proposal stage, where the capacity of the plant, the types of equipment, the construction methodology were discussed. This was followed by the construction execution stage, which began with site preparation and mobilization of labor and equipment. The harbor was made ready to allow the entry of heavy equipment. To avoid congestion at site, a separate assembly site was located downstream the river for assembling the components together. Silos and steel preheated towers were installed. Large number of tower cranes were necessary to handle heavy equipment. The kiln rings were manufactured and imported from South Korea and later assembled together on site. The plant also includes a dome for storage of raw materials. Finally, the grinding mills were constructed to crush and grind the limestones into fine powder. The final construction phase was later followed by the commissioning phase, where the testing of coolers and other equipment was carried out through a central controlling system. With that, the finished product was handed over and the cement production and operation began in 2009.